Hello everyone, my name is Abdulrahman Tammar and today I will be presenting my final project for parametric modeling and design. And the building we are talking about today is the Broad Museum by Diller Scofidio. Starting off with the mass of the building, the way that I generated the mass is by using points. So I generated the points that are representing the bottom part of the mass and the top part of the mass. And all these points are controllable through three different parameters, which are the x, y, and z axis, and all of them are connected to each other. So if I change the x axis, everything will change together. For example, if we can see here, everything is changing. And then for the bottom part, we also use the same method, but for the z-axis, we actually took the z parameter and then multiply it by 3. So there is going to be a relationship between the height of the building and the height of the openings on the mass. So as we can see them all together, these are the lines generated by the points. And then I started lofting between each edge, so we can get 4 different facades and a ceiling. So at the end we will get something like this, which is controllable by these parameters. Moving on to the facade and the subdivisions of the facade. After we generated the form, we lofted between the two edges, and after that we merged faces so we can get one unique surface. And to generate the form of the facade, where there is a notch in the middle of the facade and then there is an opening inside the notch, we rebuild the surface so we can get different points to manipulate the surface, as we can see here. Then we use list item to pick the points that are we deforming the facade with, and then by using point deform we move the points so we can generate this facade here. After that, we're gonna subdivide the surface using lunchbox scud quads, um, and the subdivisions is controllable by these parameters here. As we can see here, we can change the parameters. After that, we can see that lunchbox gave us an untrimmed surface, while our base surface is actually a trimmed surface. So in order to kill the subdivisions that we don't need, we use point and curve to kill the extra subdivisions that we don't need. After we subdivided the surface, now we are going to create the panels and the shape of the panels. We used Weaver-bed mesh window to generate the shape of the panels, the slits between the panels, and also the voids inside each panel. And after that, we use the boundaries of each mesh to generate the outer shape of the panels, and then we scale them to generate the inner shape of the panels, which represent the void. And the way that we scaled the inner panels or the inner curves is that we converted the meshes into surfaces by using list item, and then um, we evaluated the surface using MD slider, so then we can scale from the center of each curve, since these curves are not planars. And after that, we're gonna fillet the inner curves of the panels so we can get a nice little shape like this. And this shape is actually controllable, so we can fill it as much as we can. So after we generated the form of the panels, now we are gonna create a solid out of these panels. So since we have the curves of the panels, we lofted between them so we can create the outer shell of the panels, as we can see here. And then after that, we used Weaver-bed Catmull Clark to deform and manipulate to generate the panels. So in order to create the thickness, we offsetted the panels and then we moved them 2 times, each time on a different direction, one on the x direction and the other one on the z direction. And after that, we created an inner shell, as we can see here. And then after that, we lofted between the inner and the outer shell to generate here is the inner shell of the panels, and here is the outer shell of the panels. And after that, we joined everything using weaver burn, join meshes and weld, so we can get the panels here. And this is the final shape of the panels. After that, we generated the glass facade inside the building. We use the same curves that we used to generate the form, so that they all can be connected to each other, where we can scale them up and down together. So I projected the curves on the ground, and then I lofted between them to create this box, and then I scaled it down so it cannot touch the outer facade, and then construct a mesh out of that. And so we can thicken it using mesh thicken. And so at the end, we're gonna get something like this, where it can generate the opening from this side here. At the end of the day, this is the end result after operating on all the facades, including the ceiling. And I apologize for not operating on them on the video, because the file is gonna be too heavy and it will crash. As for the physics model, I took the edges of the panels and used them to generate a model using Kangaroo solver. And here I reduced the number of subdivisions of the panels so we can get a better model that doesn't crash. So I use the curves and then patch between them to create these meshes. And then I unified the meshes normals, so all of them can bubble up on the same direction, as we can see here. And then I used the surface naked edges to for anchor point as anchor points, so everything would bubble up except for the edges. And then I used edge length to put everything into the result, and then into the solver, where we can get a result like this, where everything is bubble up to the outside instead of the inside, where the original building, the panels are penetrating inside. Here we are doing something the opposite, where it is bubbling up to the outside. And here is the preview of one facade. This is the facade that has a notch in it, and this is the result of the physics model. And thank you.